differentiate sine inverse of ax and then integrate your results. So, given that y is equal to sine inverse of ax, find y prime. And y prime here, y prime represents dy dx. And then integrate your result. So, I am finding the derivative of sine inverse of ax. But now I know that the derivative of sine inverse of x is equal to 1 over the square root of 1 minus x squared. So, with the notion of this, I'm going to use the chain rule to differentiate the sine inverse of ax. So, I'm going to do it like this. I'm going to apply chain rule, and I'll have that sine inverse of ax will be equal to, it is going to be equal to the derivative of the sine inverse function times the derivative of ax. So it is going to be 1 over the square root of 1 minus ax, all that square, then times the derivative of ax in respect to x. Good. So with this now, I know that when I differentiate ax in respect to x, I have a. So this is going to be equal to a times this is going to be a on the square root of 1 minus ax all that square. So this is the value for y prime. Y prime is y dx. But now the question says, and then integrate your result. So after having the derivative, let us now integrate the result. It means we are going to have, it means we are going to have the integral of a divided by the square root of 1 minus ax all squared dx. So how am I going to do this? To start with, in this integration, I'm going to send the constant a out of the integration. I'm going to send it behind, in front of the integration sign. So I'll have it as a times the integral of 1 over the square root of 1 minus the x other squared, then dx. At this point, I'm going to use substitution to be able to complete the solution. I'm going to use the substitution u equal to ax. So if I let u to be equal to ax, I will have that du dx will be equal to a. And then to continue, I'll have that dx will be equal to du over a from here. So my integration becomes a times the integral of 1 divided by the square root of 1 minus ax becomes u squared, because I have led u to du. And then but dx is equal to, I'm replacing dx with du over a. So I will also have a here. So here I have dx, and then since I'm integrating du here, and dx is the same as du over a. So I'm replacing dx with du over a. Du over a. And the next thing I will do is to send out the a as well. So I'm going to have a over a. A over a times the integral of 1 over the square root of 1 minus u squared du. And from what I said at the beginning of this video, I said the derivative of the sine inverse of x is equal to 1 over the square root of 1 minus x squared. If you have to compare with this one, we now notice that this is 1 minus u squared, which is, so if you integrate, because from here it means if you integrate this one, you have sine inverse of x. So it means if you integrate this, you have sine inverse of u. And a on a, that is going to cancel off. And I'm going to have the sine inverse of u a plus a certain constant. But now, u was equal to ax. I'm going to replace it there and have sine inverse of ax n plus the constant of integration. Alright, thank you for watching and see you in the next video.